Okay, so I'm here with Adam on the Tark Systems booth at Data Center World London. And I guess it'd be good to get your impressions. The world seems to have gone AI crazy and therefore liquid cooling crazy, which comes alongside it. Just your thoughts as to how you see that landscape. You know, how rapidly is it developing? What's going on?
The rapid scaling of the data center market it's going faster than I think any of us can keep up with, more so than any of us can imagine. What we are seeing is as fast as we can have a pump and a liquid cooling system designed, we're getting a spec that supersedes it almost within months. And trying to be able to scale to keep up with the demands of the marketplace is not just challenging for data center operators or Tark specifically, it's a market global problem, and that's where we have the opportunity to be part of the solution to that problem. And liquid cooling and coming up with new innovative designs and how we bring that to the marketplace is what will help close that gap a bit more quickly, hopefully expediting getting to market for not just Tark, but for the rest of the industry.
And I believe that in terms of helping to address the challenges and opportunities of AI, you have developed the TCDU Series. So can you tell us a little bit about what that is and why it's, what sort of groundbreaking features that has?
Absolutely. So the TCDU Series is a centrifugal water-based pump specifically designed for direct liquid cooling in-rack solutions. We can show a little bit of what the TCDU looks like if we have some time to get through that. So here we start at the room level, going down to the CDU level. And what we have done, the TCDU Series is based on an N+1 redundancy. So we do have one pump active, one pump sitting in lieu, waiting to be turned on as it is required by the system itself. But looking within the TCDU, what we have come up with, this is our TCDU 150, can actually navigate to the performance specifications here. But with the TCDU 150, what makes that unique? We are targeting a sweet spot at approximately 1 to 2 bar, anywhere from 200 liters per minute up to 300 liters per minute. Specifically, the TCDU 150, its sweet spot is 225 liters per minute flow at 1.8 bar. The other unique thing about this is we are able to do that within a 4U rack size. So we're trying to maximize output while minimizing space claim. With our TCDU 200, we've beefed that up just a bit. The TCDU 200 is capable of 308 liters per minute, which is capable of getting us upwards of a 150 to 200 kilowatt rack. As we noted earlier, the market is dynamically expanding, and trying to keep up with that, like we'd say at Tark, it's all about the flow. And what we're able to achieve with the flow on the TCDU series is meeting today's standards, but we're also preparing for how do we meet tomorrow's standards, ramping above 300 liters per minute, and what might 400 or 500 liters per minute look like in the coming months and years. Specifically with the TCDU series, we do have one feature that is a bit of a differentiator that we like quite a bit. So as we look at the TCDU, here on the back side, we will see the motor and the PCB. What we have done here at Tark is we have used the inlet and cooled fluid moving through the impeller. We've got a crossover tube here where that cooled liquid is not only cooling the rack and the chipsets, but it's also cooling the PCB and the motor. What that's allowing us to do in conjunction with a larger bearing set, we're able to ramp the TCDU motors upwards of 5,000 or even 5,200 RPM, and that's helping us achieve that greater flow into that 200, 300 and beyond liter per minute flow. So what this also does for CDU manufacturers or data center operators, as we go backwards through the set here, with that liquid-cooled board and motor, we no longer have the requirement for fans specifically to cool the pumps and the motors themselves. In a 4U rack, real estate is tight. Space claim is wildly important. So now with the liquid-cooled board, we are able to achieve that 200 to 300 liter per minute flow without having dedicated fans for the pumps. Now, the fans may still be required throughout the CDU themselves, but not having the ability, or the need rather, for those fans to be dedicated on the pumps allows more operating area for the fluid delivery network, the piping schematic, whether it is the heat exchanger, filters, accumulators. You now have more real estate to dedicate towards what is important to the CDU itself not simply focusing on the pumps. And that combination is what we are excited to bring to the market with the TCDU series and looking forward to where we go next. It's all about scalability. Again, we've talked about 200 liters per minute, 300 liters per minute. What are the needs of tomorrow, and how can the TCDU series help us to get there more quickly, which facilitates growth, not just for ourselves, but for the industry abroad.
And in terms of what's possible into the future, because I know, this sort of almost mythical 1 megawatt rack is somewhere out there. Does that keep you awake at night, or are you excited to develop this product or another one to address the needs of that?
Absolutely. The 1 megawatt rack, they're out there. I mean, we're seeing CDUs today that are already hitting 2.3 megawatts for a CDU itself. What we are interested in is how do we not just support the in-rack solutions, but also moving into an in-row product, or even looking at single and two-phase liquid cooling loop applications. We don't have a digital twin of our RT series, but the RT series is a regenerative turbine pump focused on refrigerant-based applications, again, for single-phase and two-phase liquid cooling loops. Where we're seeing those most today are still in direct liquid cooling applications, but the RT series is also applicable in air and water side economizer solutions. So if there's a need to use ambient cooling or free cooling, we are able to use the RT series to turn off the mechanical compressor loop and focus on the refrigerant pump loop itself. What that's doing is when you're in temperate climates where, say, you are less than 60 degrees Fahrenheit or maybe 18 or 20 degrees Celsius, we're able to switch off the high-powered compressor loop, switch over to the lower-powered refrigerant pump loop, and utilize that free cooling from the ambient temperature outside. So now there's not as great of power draw. We're looking at more sustainable options, even focusing on low GWP refrigerants. And that combination is not helping us just within the liquid cooling space on in-rack solutions, but also within row solutions with larger requirements, specifically the RT series, much more geared towards high pressure, lower flow, where the water-based TCDU units are more geared towards higher flow, lower pressure. So we're trying to take both a top-down and a bottoms-up approach and find that sweet spot in the middle for whether it's high pressure, low flow, low pressure, high flow, or whether you're looking for refrigerant or water-based cooling solutions. We're trying to expand that portfolio to cover the breadth of the market demand.
I'm just wondering, in terms of liquid cooling, because obviously there are various solutions out there. Do you have any thoughts, as maybe a sort of slightly independent observer as to that? Direct to chip seems to be where we're at the moment, but the immersion cooling folks are saying they have certain advantages. Do you have any thoughts as to how the sort of industry will evolve over time?
Well, I think the evolution over time, it's happening now. And what we are seeing is not just from a direct-to-chip, but also now you're starting to see two-phase direct-to-chip applications. Immersion, some folks will say immersion's on the horizon, it's coming. I would respectfully submit that it's here. It's already part of the product mix that we're experiencing today. And at Tark, that's where we're starting to look towards our next frontier, is moving from simply refrigerant-based, water-based. How do we start exploring what the immersion market looks like, and how could either our water-based, refrigerant-based, two-phase applications, how might we be able to support the immersion push as it's coming quickly. It's not tomorrow, it's here today.
And just in terms of the sort of collaboration, I'd just be interested to know what you can share in terms of how much you sort of work on your own and how much you're collaborating with partners in various, whether it's the server folks or, just anything you can share as
so
how you do or don't work with
primarily,
other folks.
most of our internal research and development, we do that in-house. All of our bone validation testing done in-house. We are actively working with several partners in joint ventures of trying to figure out. We have our base TCDU and RT series designs. That's what we do at Tark. But there is not a one-size-fits-all model for the data center space. Every cold plate, every application, every chipset is different. So we have to be flexible and adaptable to evolve with the market. So as we see opportunities for a customer-specific application, we want to be flexible and adaptable to meet the unique demands of their individual applications and not simply say, Well, here is an off-the-shelf, repurposed HVAC or industrial pump that wasn't intended for CDU operations, but this is what we've got, this is what you get. We want to take the knowledge that we've built over the past 40 years, working on cooling systems for the medical imaging and security and bomb detection scanning systems, and translate that 40 years of experience into the data center markets. So yes, we do have our vanilla versions of the TCDU and RT series, but our focus is to be customer specific. We want to be a bespoke offering and not simply, this is what we have, this is what you get. We want to understand the unique needs of our customers' applications, what demands they're facing, and what market pressures they're seeing, help them scale and get to market faster.
And maybe just finally then, at the moment, AI is sort of all about, seems to be about the gigawatt factories, the large language models, but the inferencing is perhaps more interesting longer term, the sort of distributed, maybe smaller data centers. Is that something you're already got covered, or will you be working on solutions?
So we've talked about the gigafactories and the high density compute applications. The TCDU specifically also serves the colo market, where it's more about server space and how many clients can we bring into one server. With the base TCDU models, those are going to be designed to be more so common and more I don't want to say less adaptable, but more focused on providing consistency and more standardization. So we do offer that bespoke opportunity to work with the hyperscalers, to work with the gigafactories if they have a specific need, but also if you are looking for something that's more general for a co-location or maybe an edge facility, the TCDU base design is what that is specifically designed for. It's more about how many servers can we cool, and can we do that with the standardized unit that's traversable across multiple platforms.